Hello everybody, welcome to the Henstitute help session, and on this one, the very last set of the free fall problems, we have kind of actually a little bit of both. We have some free fall, but we also have some horizontal motion because the raft itself is moving horizontally at a constant speed, and what we're actually trying to find is what that speed is. So in essence, what we're going to need to figure out is the time it takes this rock or this object that they drop to fall 75 meters. Because if you read the problem, that they're standing on this bridge 75 meters high, they see this boat or this raft, they're trying to hit the raft. So they drop a stone from rest, so we know VI is 0, when the raft has 7 more meters to travel before passing under the bridge. The stone hits the water 4 meters in front of the raft. Find the speed of the raft. So if I think of speed being distance divided by time, the distance that the raft has traveled is it was 7 meters from the bridge, and then when the stone hits the water is 4 meters from the bridge. So really the distance would be 7 minus 4, or in other words, it has traveled 3 meters. So we've got that part. What we don't know is we don't know the time underneath. So that's where all this stuff is going to come in. So the stone is going to fall 75 meters, so I'm going to make that a negative 75 meters. It starts from rest, so VI is going to be 0, and we're trying to find time. Seems this is going to be a recurring theme, and then we know the acceleration of gravity, 9.8 meters per second squared. So the idea is using this bit of information, let's figure out what time is. So since we don't have VF, it looks like we're back to our normal VI y equals VI t minus 1/2 gt squared. Since VI is 0, that part disappears, and you get, this is actually not a bad equation to have in your little repertoire of equations, because it's, if you know how high you drop something from, that's why, then you should be able to figure out how much time it takes to hit the ground. Now remember, I'm always putting in y as a negative number because it's falling, because VI is 0. If I was actually launching something up till it has a final velocity of 0, and I'm trying to find the time to rise to that, I can actually use the same equation like we saw with problem number 10 and also get it. So that's a little bit of help with that, and I hope you enjoyed.